Good morning, fifth grade. It's Dr. Milam. Hey, guess what? Today is Thursday and tomorrow is Friday, and then you are off for an entire week. I know it feels like you're like already off, but at least you know you don't have any work to do unless you need to spend that time catching up. You may have to. When we come back from spring break, we're going to start a brand new module and I'm pretty excited about that. So this will be the last lesson for this module for right now. Do not throw away your books because there were a number of lessons that we did not get to in this particular module, but we're going to come back to later on. So don't throw away your books, okay? I am going to post your final assessment for this module separate from this assignment, okay? So I want you to just do this assignment and then I'm going to post your measuring up piece separate because that will be a longer measuring up piece that will be across the entire module, okay? So it won't be just for this particular lesson. So it might take you a little while to do it. I want you to take your time. Please do not rush it. Don't be a professional clicker. I can tell how much time you're actually spending on the assessment. I know who went through and just rushed and clicked anything and you didn't care about your score. But I'm saying to you that you really do need to care about your score in this particular assessment, okay? I love you guys so much. You're troopers. I know that you're working hard. Kudos to you all who have completed your all of your assignments. You're really trying to stay on top of it. For the rest of you, I encourage you to get yourself on a schedule and use this next week to do it. Like I said yesterday, tomorrow I want us to go into Khan Academy, just kind of get you kind of rolling with that. I will post a trial assignment like I did before, and then I want you to go on the My Own and read a little bit about math and basketball, okay? Or math and baseball. I haven't decided which one I was going to choose yet, okay? All right, well, let's dig into the lesson. This is lesson 31. Our objective is to divide decimal dividends by non-unit decimal divisors. What in the world does that mean, Dr. Milo? Well, that just means that we're going to do the same thing that we've been doing, except for we're going to talk a little bit more about the standard algorithm. I started a little bit earlier, but today we're really going to do it. We're just going to move decimals and divide, and that's going to be it. Hopefully, it won't be as long as yesterday's and the day before. We're going to start with the application problem, okay? So it says that, and I'm going to go ahead and let's see. I think I kind of want to cover this up. I know you already kind of saw it, but let's cover it up for a moment, okay? It says a cafe makes 10 8-ounce fruit smoothies. Each smoothie is made with 4 ounces of soy milk, 1 to 3/10 ounces of banana flavoring, and the rest of the 8 ounces is blueberry juice. So 4 ounces is soy, 1 to 3/10 is banana, and the rest is blueberry juice. About how much do you think that's going to be? If I've got 8 and here's 4 here, and this is about 1.5, right? We can do a little bit of estimating. So like 4 and 1.5 is 5.5. So if this is 8 ounces, that means that I'm probably going to have around 2.5, maybe a little bit more, maybe a little bit less. Let's just figure it out, okay? But it says how much of each ingredient will be necessary to make the smoothies. Well, how many of them are they making? Did you notice this? That they are making 10 8-ounce fruit smoothies. So, here are my cups, and each one of these has 8 on the inside, 8 ounces of deliciousness. I don't know. Do you know about Jamba Juice? Like, I think that a lot of them have closed now, but that was like one of my favorite places to get a smoothie. I know they have something called Smoothie King. My son absolutely loves and adores that too. Anyway, all right. So, how much is the rest. How much is the blueberry juice? Because in order for us to find each ingredient, we've got to find the blueberry. So just like I was just estimating, I just want you to see what they did. So they drew a tape diagram and they wrote the 4 for the soy, and they wrote 1 3/10 for the banana, and then the blueberry is what we don't know. We know how to do this. It's been a while since we've done a problem like this. So what did they do? They took the 8, they subtracted 4, subtracted 1 3/10, and got 2 7/10. And that was really close to our estimate. If you really need to see this out, so the 8 minus 4 you guys get. So that's 4. And then we've got to subtract 1 3/10. Be very careful when you don't see a decimal here that it's always behind the number. Always, always, always. And then they just subtracted as if these were regular numbers, like having 40 minus 13. I'm setting you up for today. So 40 minus 13 is really just 27. But remember that it wasn't 40, it was 4 and 1 3/10. So wherever the decimal is where is what I need to do to bring it down. So it's really 2 7/10, and that's the blueberry. All right, well then how much is going into 10? So if I'm gonna have 4 ounces in each one, so that means that it's 4 times the 10, which is 40. The banana is 1 3/10, and I'm going to have 10 smoothies. So 1 3/10 times 10 is just 13. And if you notice, they're just moving that decimal over to the right. Why? Because we're multiplying by 10, not dividing by 10. It's like saying having 10 of these. So if I do like 1.3 plus 1.3 plus 1.3 and keep going until I have 10. When I add them all up, I'll get 13. Same difference. That's why they're moving the decimal to the right. The blueberry was 2 7/10 ounces, and so we're going to make 10 smoothies, and so we need 27 ounces. So what do we need? The cafe will need 40 ounces of soy milk, 13 ounces of banana, and 27 ounces of blueberry juice. Okay? All right, we're going to dive right into our problem set. Going to change the color here. And so, how would you divide these two decimals? Well, remember the last lesson we multiplied top and bottom by the place value of our problem, and particularly the denominator, okay? So this is tenths. So in the last lesson, we multiplied both by 10, okay? Or you may have written this in fraction form and then multiplied it. You definitely can do that. So multiplying by this by 10 moves the decimal to the right. So this is 348, and then if I move the decimal here, then that just becomes 6. So now look at this. This looks like a regular division problem that we're just taking 348 divided by 6. So 6 can't go into 3. You guys know that. 6 goes into 34 how many times? 5 times, because 6 times 5 is 30. And so 34 minus 30 is 4. Bring down the 8. And this is looking really promising. 6 goes into 48 8 times. 8 times 6 is 48. And so actually my answer is 58. You say, well, don't I need a decimal? Well, we moved the decimal over by multiplying by 10. So actually the answer to this problem is just 58. I don't need a decimal here because I moved both of them. The only time that you're going to need that decimal is if you're not moving it, or if you moved it and you have a decimal left. And you're going to see that in a couple of examples. In this particular example up here at the top, we needed to keep our decimal in because we're subtracting this decimal from this decimal, which is going to give us a decimal. Okay, all right, let's do this next problem. But this time I'm just going to move the decimal. Okay, I'm going to still write it as 7 36 divided by 8 hundredths. And this time, I'm going to move, let's do this in a different color here. Let's move this decimal 1, 2 spaces, okay? The book is also going to call that like estimating, okay? So really, estimating in this problem set will be like, what if we just wrote the numbers without the decimal? Or what if we just move the decimal, both top and bottom, the same number of spaces? Okay, that's what that's going to mean. So if I move this 2 decimals, it's the same thing as if I multiplied it by 100. Same difference, okay? But I'm not going to write that any longer. I'm just going to write 736 divided by 8. I hope you're not confused here. It's kind of like seeing the numbers without the decimal, okay? So this becomes then a regular old division problem. So 736 divided by 8. Oh, what is your multiplication facts? How many 8s go into 73? 73, come on, think. There are 9. 9 times 8 is 72. And so this becomes then 16. 8 into 16 is 2, and so we have a remainder of 0. Thank goodness. So again, like I said, because we moved the decimal place, this is just our answer, 92. It's probably a little bit easier than what we've been doing all along. And you know that the books be doing the most. They always want you to understand the concept first before they teach you the algorithm. And they do that because we don't want you to just blindly be doing division just for the sake of doing it, or doing math just for the sake of doing it. You actually need to understand why you're doing it. What does it mean to divide 2 decimals? Okay, or even what does it mean to divide? All right, here we go. Let's get a magenta going. All right, so 21 and 56 hundredths divided by 98 hundredths. So again, we're going to move the decimal place to the right 2 spaces. So that decimal place is there. So that becomes 2,156. And we're going to move this decimal place to the right 2 spaces. And so that just becomes 98. If you're noticing that when it's behind the number, we don't really have to write a decimal. Okay, so again, this is just regular standard old division. Okay, so we're going to divide this 98. Oh boy, how many times does 98 go into 2? It can't. 98 into 21, it cannot. 98 into 215. Well, think about this. Let's estimate. 98 is almost 100. And then this 215 is 200, right? If we're estimating. So I wonder if it would go in 2 times. Okay, let's see. Because there are 200s in 200. All right, so what's 98 times 2? All right, well, 8 times 2 is 16, carry the 1. 9 times 2 is 18, plus 1 is 19, and that probably is the amount that can go in. Okay, let's keep going. So when we subtract these two, what's happening here? We're going to regroup here and borrow 1 from here. So that becomes 15. 15 minus 6 is 9. This was a 1, so we're going to regroup here and borrow 1. Here it's a little tricky for me. And so then this becomes 10. And I'm just going to cheat and do that. So that becomes 10. And so this is 1, which is 19. So what I was doing was 215 minus 196. I'm just writing it here for clarity's sake. And so there are, to get to 200, there are 10 From 196 to 200 is 10. And then, oh, I'm sorry, to 200 is 4. What was I doing? Is 4. And then 196 to 200 is 4. And then to get to 215 is 15. So we did our subtraction right. Look at that. Dr. Mom did it another way. So that's 19. We know that this is correct. So we're going to bring down the 6. How many times does 98 go into 196? Okay, well, this is almost 100. This is, oh, we've got it right here. Look at that. Goes in there 2 times, ladies and gentlemen. So 2 times 98 is 196. Let's get rid of that. Not sure what that is right there, but we're going to delete it. All right, 96, we get a remainder of 0. And so the answer to this problem is 22. All right, I want to do C because C is a little bit different. In this case, if we just talked about moving the decimal, we would move the decimal just one time, okay, here, just one time. So this number then would become 455 divided by what? Well, we're going to move this decimal one place too. So if you notice, we're moving the decimal the same number of decimal places, okay? So then this becomes just 7, and you can do the division for this one on your own. This one here, though, is a little different. So we've got 4 and 55 hundredths divided by 7/10. So now that's a little different than what we've been doing before. So which one, the top or the bottom, drives the move? It's going to be the bottom one, okay? Going to be the bottom one. So we're going to move this to the right one place, okay? That means, watch this, we're moving this to the right one place. So that means that this top becomes 45 and 5/10 divided by 7. That's why I wanted to do this problem, because we still have a decimal. So does that mean we move the decimal again? Well, if you get it, you can. If you get that, let me just do it for you. If you get it, you can move it, okay? So that means I'm moving the decimal, but here's what's tricky. If I'm moving the decimal here, that means I've got to put a 0 here. So I've got 455, divided by 70. Okay? If that's confusing for you, then let's just go ahead and do the division here. Whoops. So it's 45 and 5/10 divided by 7. Okay? Does that make sense? Okay, well, let's do the division. So 7 goes into 45 6 times. If you notice where the decimal is here, the decimal is here, up here. So 6 times 7 is 42. And so this is 3. And then we're going to bring down the 5. And so this is 7 times 5, which is 35. Okay, so what's my answer? It's 6 and 5/10. And so if you do this division here, you're going to get the same exact answer. Okay, so let's do it. 455, not 455 divided by 70. So 70 can't go into 4 or 45, but 455. So that's 6 times, if you can see that, that would be 420. Okay, so I've got 35 left over. 70 can't go into 35, but if I add a decimal, and you see, you're already going to add a decimal. How many times is 70, though, go into 350? That's 5 times, and so I'm going to get the same answer. Okay? You can do the replay on this one right here so that you can understand. I'm going to go right into the problem set, okay? Remember when I said that they're going to ask you to estimate? And so part of their estimation is saying, well, what if we multiply top and bottom by, no, I'm sorry. Their estimation is saying, well, 7, if we looked at just the number, 78 and 4/10 is really like saying it's about 770, and they did that so that they could easily divide that by 7. Okay. I'm a coin toss on the estimation. You don't really need to do that right now. I think I just want you to practice the actual division. So let's set this up. I do want you to set this up though as 53 and 2/10 divided by 4/10 because I actually want to see, I want to see you move the decimal. So I'm moving this one place here. I'm moving the decimal one place here. And so what am I really dividing? 532 divided by 4. And because we moved both decimals, whatever answer we get is the answer that's here. Okay? So that means that 532 divided by 4. 4 goes into 5 one time. Watch that. And this is 4. This is 1. I'm going to bring down the 3. 4 goes into 13 3 times because 4 times 3 is 12. I'm getting into my other problem here. This is 1. I'm going to bring down this 2, which is 12. 4 goes into 12 3 times. And so 12 minus 12 is 0. So that means my answer is 133. It's not even approximate. It's exactly 133. Okay? All right, let's do this one. I think you're getting the hang of it. This is 1 and 52 hundredths divided by 8/10. Watch it on this one. Remember that the bottom number is what drives it's what drives the movement, how you're going to move it. So we're going to move this how many? 1. And we're moving this how many? 1. Careful, careful, fifth graders. So now this is 15 and 2/10. I still have a decimal divided by just 8 because it's behind the number, so I don't need it. So I'm going to go ahead and do the division here, okay? If you get it and you want to move the decimal again, you can. So it becomes 152 divided by 80, but you're going to still have a decimal, okay? So this is 15 and 2/10 divided by 8, and so divided by 8. So 8 goes into 15 one time, not 2. That would be 16. So this is 8. 15 minus 8 is 7. Bring down the 2. Very nice. So that means that 8 goes into 72 9 times. Be very careful because look, right here I have this decimal. I've got to put that decimal up there. And really before you start, you probably should put that decimal there. 9 times 8 is 72 to 0. And so my answer is 1 and 9/10. When you do this, you get the same thing. And I'm not going to do that right now. I'm going to keep going because I want to get to the word problems. And there are not a lot of them, okay? I do want to keep doing these two, though, because we have, here we've got 2 movements. Here we've got 2 movements. Remember that second number is what's going to drive it. Let's use something a little darker so you can see it. So this is 9 and 42 hundredths divided by what? 3 hundredths. And so here we go. Keep going. So we're going to move the decimal point. Move the decimal point. Let's do that with orange. All right, the bottom is what drives it. How many movements did we have? We had 2. And so we're going to move the decimal place here. 1, 2. Okay, so that means we've got 942. And then on the bottom, we've got just 3. And if when you get really good at this, you can do division without having to write it out like this. Okay, and let me show you what you would do. You know Dr. Mom's always trying to make you smarter in math. So look at this. 3 goes into 9 how many times? 3. There's no remainder. So I go right to the second one. 3 goes into 4 how many times? 1 time, but there's 1 left over. So that 1 makes the 2 12. So 3 goes into 12 4 times, and my answer is 314. Now, a set 2, I know you're saying, oh my God, Dr. Milo, what in the world? So let's do the division. 942 divided by 3. I want you to see that Dr. Milo used the same language. I just did it in my head. 3 goes into 9 how many times? 3. 3 times 3 is 9. Remember, I said there was no remainder because it goes in evenly. So there's a 0 here. I'm bringing down the 4. 3 goes into 4 how many times? 1 times. And 1 times 3 is 1. Remember I said there was 1 left over. And you're going to bring this 2 down. And so 3 goes into 12 how many times? 4. And then 4 times 3 is 12. And there's no remainder. So it's 314. All right, let's keep going. Let's keep going. I like to move it, move it. All right, 39 and 36 hundredths divided by 96 hundredths is what? I'm going to move that decimal place over to the right, 2 spaces. I always start with the bottom here because then that again drives 2 spaces. So on the top I've got 3,936 divided by 96. Oh, I think you guys get this. All right, so how many 96 goes into 393? Because I'm doing the division. Well, this is almost 100. This is almost 400. I wonder if 4 will work. So let's do 96 times 4. I don't know if that's going to go over or what. So 96 times 4 is 24. That's the kind of estimation that I want you to do. Okay? Knowing how many times something goes in, don't spend a lot of time doing 96 times 2, 96 times 3, 96 times 4. That is a time waster. That's where I want you to do your estimation. This is almost 100. 96 can't go into 3 or 39. So what I'm doing is finding how many times can 96 go into 393. So I'm estimating 96 is almost 100. 393 is almost 400. So that means that there are 400s and 400. That's why I chose to multiply 96 by 4. Let's see if it's going to be too much. So 96 times 4 is 24. 9 times 4 is 36. Plus 2 is 38. And it's not too much. So that means that my first number is 4. Okay? All right, so 3,000. I'm just going to do this here because I want you guys to be confused. Divided by 96. So I know that this is 4. I don't have a decimal here, so I'm just dividing. I just found out that that was 384. And now I need to subtract these two. I'm going to borrow one and regroup, and I get 9. Okay? Bring down the 6, and thank God it goes in evenly. And so, and I'm gonna say that it's 41. Okay? All right, do the replay. This right here is asking you to go ahead and do the standard algorithm. Up here, it was asking you to estimate. So you could just go ahead and do the standard algorithm for these 4 problems here. If you notice here, they're using the thought bubble to do exactly what I did up here, which was to move the decimal, the number of places that you need to in order to divide. So in this particular case, the bottom drives it. You're just moving it 1 over. That's 3. Move the top 1 over. And so that's just 462 divided by 3, which is 154. Okay? And so then they want you to just do the division here. So however you do it is totally, totally fine. 3 goes into 4 1 time. 1 times 3 is 3. 4 minus 3 is 1. Bring down the 6. Again, this is just regular division. 5 times 3 is 15. And 1 left over, bring down the 2. And so the final answer is 154. Okay? All right, I'm only going to do, let's see, let's do this one because I did this one where you're only moving this. Look at the bottom here. The bottom is going to have 2 movements and you only have 1 decimal here. So let's do what I had done where we extended. I think we did that way back here. We did, okay? Let's do that for this problem, as I think you guys can do these on your own here. This problem then would be 15 and 6/10 divided by 24 hundredths. 24 hundredths, okay? Don't really need that 0 in front, but if you want me to put that there, then I will. All right, I'm going to do this in another color. Let's do green. So remember that the bottom drives it. So if I've got 2 decimal places down here. So I'm going to move it twice. But look at this, it only has 1. But I still have to move it twice, okay? So watch me. So I'm going to move it 1, and then I'm going to move it again twice. What's going to go here? You guys said it. It's going to be 0. Okay, so what numbers am I dividing now? 1,560 is what I'm dividing by 24. Oh yes, oh yes, oh yes. All right, let's see if I'm going to do this in my head. Okay, so 24 goes into 156. I don't know if you can really see that. It's like saying 25 goes into 150. I don't know if you can see that. Well, let's just go ahead and do the division for this. So we've got 1,560 divided by 24. So let's see, 2 goes into 15 7 times. Look at me estimating. 2 goes into 15 7 times. 7 might be too high. Let's try 6. 6 times 24 is what? 6 times 4 is 24. So 6 times 4 is 24. Carry the 2. 6 times 2 is 12. Plus 2 is 44. And I think we did our estimation right. Okay. If you're not sure, do division however it is that works for you. How many 24s go into 120? Well, this ends in 0. Watch Dr. Milam estimating. Because I don't know it off the top of my head. I'm going to guess, or I'm estimating. It ends in 0. So 4 times what number gives me 0? 5. You say, well, remember, I'm trying to get the number over here to be 0. So I know that 4 times 5 is 20. Well, 4 times 4 is 16. 4 times 3 is 12. 4 times 6 is 24. The only number that I can get that ends in 0 is 4 times 5. So let's see if that works. 4 times 5 is 20. So here's my 0. I'm going to carry the 2. I used this one already. And then 4 times 2 is 10 plus 2 is whatever works for you, okay? Dr. Marla's just showing you some estimation. If you get it, go with it. If you don't, it's cool. It's all right. All right, we only have 2 problems to do. Isn't that fantastic? All right, so if volunteers set up a water station, first of all, the total distance of a race is 18 and 9/10 kilometers or kilometers. A, if volunteers set up a water station every 7/10, including one at the finish line, how many stations will they have? So I've got 18 and 9/10 divided by 7/10. I'm going to move my decimal over 1 space. I only have 1 movement here. So I've got 189 divided by 7. Do it in your head. How many times is 7 going to 18? Only 2 times. 2 times 7 is 14. There's a 4 left over, and so 7 goes into 49 7 times. Okay, so it's 27 stations. Remember what we're answering. It's 27 stations, okay? You didn't get that? Do the regular division, okay? All right. It said if volunteers set up a first aid station every 9 kilometers, including one at the finish line, how many stations will they have? Same division problem. 18 and 9/10 divided by 9/10. And so I'm going to move the decimal. Let's use lime green. That's kind of cool. Move the decimal over one time, move it over one time. And so I'm doing 189 divided by 9. Oh, I hope that you see that's 21. Because 9 can't go into 1. 9 goes into 18 two times. No remainder. 9 goes into 9 one time. And so it's 21 stations. Come on, 5th graders. You got to get ready for 6th grade. Dr. Mom was getting you ready, getting you ready, getting you ready. All right, in a laboratory, a technician combines a salt solution that contains 27 test tubes. Each test tube contains 600 liters of the solution. So if I drew a tape diagram with 27 pieces, each one, and let's see, are you okay with this if I do this? If I do that, this is, and then this is 6, and then I do dot, 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 and then this right here is 600s, and there are 27 of them. You okay with that? Hopefully you are. Hopefully you are. There's 27 of them. Each one has 0.06 liter of that solution. So it says if he divides the total amount into test tubes that hold, so look at this, it says if he divides the total amount into test tubes that hold 3/10 liters, then how many test tubes will he need? So he's got 27 test tubes that have this salt solution in it. So he divides the total. So that means that he needs the total of all of this first. Then he's going to pour them into 3/10 liters. He must have some experiment to do or something like that. I have no clue. So I need the total here. So I've got to do the total. So 27 times 6/10 is what he's doing here. Okay? Now, I could move it over, but I don't have a decimal here, but I could still do that if I wanted to. Or I could really take the answer and move it over 2 decimal places, okay? So whatever works for you, why don't we do the movement, because we've been doing the movement. So then if I move this decimal 2 spaces, then that means that I've got just 6. But I've got to move this over 2 spaces, right? Does that make sense? All right, maybe not. Okay, so let's do the multiplication. 6 times 7 is 42. And so here's my 2. I'm going to carry the 4. 6 times 2 is 12. Plus 4 is what? Let's see, where'd that come from? Oh, Lord. What's happening here? Stop. Let's see. I don't know why this is doing this. Okay. So 6 times 27 is what we're doing. Okay. So 6 times 7 is 42. 6 times 2 is 12. Plus 4 is 160. Why am I blanking? 6 times 2 is 12. It's 16. Good Lord. Dr. Milo, really? Okay, so we've got, but then we've got to multiply by the 0, okay? So we've got, what in the world is happening today? I don't know what's going on. All right, here we go. So this becomes a 0. This is my placeholder here. So 0 times 7 is 0, and 0 times 2 is 0. So what do we have? We have 162. But we've got 2 decimal places here. So actually we've got to put our decimal place right here. So really we've got 1 and 62 hundredths liters of a solution. So now we've got to take 1 and 62 hundredths, sorry that this was kind of brutal, divided by 3/10 because I want to know how many test tubes that can hold 3/10 liters. How many test tubes do I have? So I'm going to move this 1 decimal place. Watch this. I move this 1 decimal place. Be very careful. So that now becomes 16 and 2/10 divided by 3. So let's do the division. 16 and 2/10 divided by 3. If you see this, you would know that this goes into 5 times. Here's 1, bring down the 2. So I got 3 into 12, which is 4. But where's my decimal? My decimal is here. Okay? So I need at least, what? 5 test tubes. I really need 6. So I'm going to say approximately, it depends on his science experiment, right? So it depends on if he has to use all of the solutions, or can he have some left over? Because then this would mean that that he needed either 5 or 6. 5 or 6, depending on like what his experiment was, right? Technically he would need 6, but that last piece doesn't fit, okay? Because you can't have part of a test tube, right? Can't have part of it. But the same token that we have, well, this represents test tubes, okay? So you can't have part of a test tube. So it's either 5 or 6, depending on his experiment. Okay? All right, well, that concludes lesson 31. Yay, we're done with this module for right now. Don't throw away the books, okay? Because we will come back to lessons 32 and 33 later on when we do module, I think it's module 6. We'll come back and grab a couple of these lessons that is going to prepare you for that, okay? And that's not until the end of April, okay? Beginning of May. All right, then. You guys take care. Happy studying, and have a great day. All right.